Hello everybody, I will start my today's another live coding session. In my today's video, I will solve the question, longest palindromic subsequence. So yesterday I solved the question, longest palindromic substring. But today it's the subsequence version. And I will solve this question in two approaches. Number one, top-down DP. Number two, bottom-up DP. So let me get started. So in this question, I'm given string s, and I will find the longest palindromic subsequence of length 3. I will find the longest palindromic subsequence's length in s. And subsequence, the definition of subsequence, is a sequence that can be derived from another subsequence by deleting some or no element without changing the order of the remaining elements. Okay, so in this question, the input should be a string s, and the output should be the length, which is an integer. Okay. So for example, if I'm given BBBAB, in that case, the longest palindromic subsequence is BBBB. I skipped A, and I get BBBB, and yep, BBBB can be read the same forward or backward. Okay. And the next example, CBBD, in this case, I will skip C and D, and I will get BB. That is the palindrome, and whose length is 2. So I return 2. Okay, so that's what I will do in this question. So let me get started with the top-down DP approach. So I will tell it straightforward. The top-down DP interface looks like this. So I can think of it in this way. So when I have the string like this, and I will take a look at start index and end index. Obviously, for 3, the start index should be 0, and end index should be the last index in the string. And I will take a look at the start index and end index. Start char is equal to end char in this case. So in that case, I will definitely choose B and B and include it in the longest subsequence. There's no benefit that I don't give it up. So I use B and B. Then I will try to find the longest subsequence in this range. Yeah. And now something interesting happens. B is not A. So that being said, I have two choices. So number one is I will choose this B and give up this A. But I still cannot say this B can be included in this palindrome because I have to find the pair of this B in the palindrome string. So the first option is I give up the end A. The second option is I give up part B and try to find the palindrome. And the difference from the first case is that in this case, I should always choose B and B. So these two characters are included in the palindrome subsequence. So I can say this is the maximum length of the palindrome in BBBAB. However, in this case, BBA, as I said, I still don't know, in this case, the start B has a pair inside of the inner string. So I can say this can be, like this. Yeah. So basically, I can solve this question recursively, and I can use the dynamic programming because once I find the, you know, longest palindrome length in the specific range, I don't have to compute it anymore. I can memo. I can put it in the cache and avoid the redundant work. So I can use, you know, um, um, dynamic programming. Yeah. Okay. So that being said, let me implement the solution. Okay. Oh, by the way, the base condition is when I have only one string, one character. In that case, I should return one because only single character can be in the center of the palindrome, like BAB. A can be the included in the palindrome because it can be the center without a pair. Okay. Aside from that, what I can tell is if there are two characters, I still can use this kind of DP formula equation. So I don't take it as the base case. Okay, that being said, I will implement my solution. Oh no. Okay, so this is it. So I will explain the recursive function. So in line 23, I will check the base case. If start index is equal to end index, that is the center char. So I return 1. Otherwise, if start char is in char, as I said in line 7, I will return 2 plus the max length of start plus 1, 2, and minus 1. Otherwise, I will give up either of the start or end. And I will check the length of the inner string without start char or without end char and return the bigger one of them. Okay, so let me quickly walk through my code. For example, in this case, I expect 2 to be returned. Okay, in this case, in line 21, I will call max length with 0 to 2. Then in line 28, start is 0 and end is 2. Because start is not end, I will go to line 31. Start is not end char because they're B and A, I will go to line 34. And I will return the maximum of something and something. And those somethings are max ranks of 1 to 2 and max ranks of 0 to 1. Okay. So I have to think 1, 2, and 0, 1. And for max ranks 1, 2, I come back to line 29 and start is 1 and end is 2. They're B and A. They're not the same, so I go to line 36, and again, I will give up index 1 or index 2. And I get 2, 2, and 1, 1. And now, for max set ranks 2, 2, start is equal to n, so this is 1. For 1, 1, it's the same. It is 1. So this should be 1 and 1, which is 1. Now let's think of max rank 0, 1. For this one, in line 32, start is not equal to n, so I go to line 35, and first char is b, and end char is b, which is the same. So I go to line 36, and now I get 2 plus max ranks of 1 and 0. Oh, obviously I forgot to cover this case in the recursive function. Sorry, I spot one mistake here. Okay, so in this case, obviously I should return 0 because I don't have any string I can return. So I will return this. Okay, then I can say this is because this returns now 0. Now I compare 1 and 2 and I get 2, which is as expected. Great. Okay, so now let me execute my code. I see. Okay, and also I have to share this s as the instance variable. Good. Okay, so now it's accepted. I will do the complexity analysis. So the time complexity should be n squared because in the recursive function, start and end pair should be n squared combination. And for each recursive function call, aside from the another recursive function call in line 42 or 45, 46, it takes a constant time. Yeah. And also, once the result of this recursive function call result is calculated, this takes only the constant time. So I can say I have to think of each recursive function call and their n squared function calls with different arguments. For each, it takes a constant time. And I get the n squared times 1, which is n squared. Yeah, so this is the time complexity. For space complexity, the only space I need is the recursion stack. So in the worst case, I will start and end with the beginning of the string and end of the string. And each time, the range of the string I'm taking a rook is um, decremented by length 1 or one length 2. So at max, it takes n recursions stack. So it should be O of n. That's the space complexity. Okay, good. So now I will think of the second approach, which is bottom-up DP. So basically what I would do is quite similar to the top-down DP. So what I would do is, if I get this, I will think of the DP table, which is 2D. Which looks like this. So here, I mean, each cell represent, say for this one, this represent string B. And this represents, for example, B, 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 A, because it starts with the first B and ends with A. For example, this one represents B because it starts with the last B and ends with the last B. And obviously, this cell is something I can ignore because it's an invalid string, which means that start char is after the end char. Okay, so that being said, my task is to fill in this DB table with the length of the maximum subsequence for each substring. Then I will return the maximum one. No, and I will return the maximum, sorry. I will return the length which is filled in into this cell. Yeah, so that's my task. And for this, the first thing I can do is I can fill in this cell, which are in the diagonal of the, which means that the length of the string is exactly 1. Then I will try to fill in the table. So let's think. I'm thinking of this range. And completely the same thing can be done as the top-down DP. If the start char is equal to the end char, that should be 2 plus the maximum subsequence of the inner string. If they're not the same, I will compare the case when I give up the first char and the case when I give up the last char. And the maximum of the subsequence in each shorter inner string is the one, the maximum subsequence length of the original string. So that being said, for example, this begins from B and ends with B. They're the same. So I can say I should choose these B and B. Then the remaining string is 0, empty. Yeah. Okay, so let me make a bit of the difference here, update here. So I will fill in the case when the substring length is 2 as the base case. So for example, this BB, it should be 2. For this should be this start with B and with B, so 2. This start with B and with A, so this should be 1. Because I can choose either B or A. For here, it starts with A and then this B, so this should be 1. So I will fill in these two, stripes, kind of stripes, as a base case. Then I will think of this. Here, this is BAB. So I definitely should choose B and B. They should be 2 plus this maximum and length of the string B. I can say this should be maximum of this. And for example, for this, okay, I will do this one. For example, this one, this should be BBA. B is not A, so I will think substring, inner string BB or BA. BB is this one, and BA is, think of this, and BB is this one, BA is this one. So I can say, when I'm thinking of this cell, so if start char is equal to end char, L is, what is it? So 2 plus y. Otherwise, L is maximum of x and z. So obviously, this is almost the same as the one DP equation I built in the top-down DP in line, where was it? 7 to 9. Yeah. I can use this. And that being said, what I have to take care is that the order of filling in cells. Because to fill in L, I have to know X and Y and Z values. So what I can do is, firstly, I fill in this stripe, 1, 1, 1, 1, 1. Then I will fill in 2, 2, 1, 1 stripe. Then I fill in this and this and this. And then I fill in this and this and this. Sorry, this and this. Then I fill in this. Then I will return this. Question mark, question mark, question mark. Okay, the order matters. That's what I can say. Okay, so that being said, I will start the implementation. But let me sort out the approach first. So initiate DP table, then fill in base case 1, which is single char case. Number 2, fill in base case 2, which is 2 char case. Then I fill in cells in order of stripes. Hope it works. Hope it makes sense. And then I return start to end. Okay, so this is what I would do. So let me get started. So this is the DB table. And now I redo the base case 1. So okay, so this is the first case. So the second case is this. And for this, if two chars are the same, index I plus I plus, char at index I and char at index I plus 1 are the same, this should be 2. Otherwise, it should be 1. Okay. Now I've filled in 2 base cases. And now I will fill in do line 76, fill in cells in notable stripes. I've finished this and this. Yep. So what I will do next is this one. By the way, by the constraint, length of S is at minimum 1. So the DP table should be at smallest 1 by 1. Anyway, I will do the line 76. So I firstly start with start and 0, 0 and increment start each of start and end by 1. So from 0, 0, then 1, 1, 2, 2, 3, 3, 4, 4. Then everything 0, 1, has 0 and 1. And I increment each of start and end. So it should be 0, 1, 2, 1, 2, 2, 3, 2, 3, 4. So in that way, I can fill in the cells in the stripes order. So I start with okay. So I iterate the end index from 0 to n minus 1. Then start should always begin with 0. Then I would say I have to check start and end are in the range of the string. And then after filling in the DP cell, I increment start index and end index. Yeah. And when I come back to line 94, I can check start and end are in the valid range. Good. And what I've noticed here is that instead of doing line 85 or 88, I mean, filling in the base cases in this way, I can just include this base case here in line 95. So I can say this. Okay, so in line 101, what I will do is do something like line 70 to 71. So if start char is equal to end char, there should be 2 plus this. And otherwise, they're not the same, so I guess the maximum. This. Okay. Let me clean it up a little bit. Then finally, I will return dp0 to n minus 1. Okay. And I'm pretty sure that it works in the cases like the length of the S is 1 or 2. So I think I don't have to distinguish those cases. Okay, so now let me execute my code. No, it's wrong. That's it. Okay, I see. So the problem is that I initiate start here, but this start is updated in line 99. Yes, it's okay. And oh, that's the problem, I think. Sorry. Let me print out the DB table. Ah, no, sorry. This is the problem. I don't have to add 2 in line 77. Okay. Good, accepted. Okay. So for this approach, I will do the time complexity analysis. For the time complexity should be n squared because I have to fill in each of the 2D DB table, which is n by n. Obviously, I don't have to fill in the, half of them, but still the time complexity should be n squared. For space complexity, it should be n squared because I need the 2D DB table. And aside from that, there's no data structure, which is non-constant. Okay. So now I could solve this question in with top-down DP and bottom-up DP. Let me do a little bit of follow-up. The follow-up is I will return the longest subsequence instead of the length of that. So that's my follow-up. Let me do with top-down DP. I think this is quite simple. I just have to return the string instead of the length from each recursive function. So I've written this, and oh, this should be this. And here I should return this and this and this. Then, yeah, I think this is it. And over here I have to return the, sorry. This is the mark subsequence. I will return the ranks of it in the end. So that the test passes in read code. Let me check. Okay. No, it doesn't work. Why is it? Oh, probably this. Here I return the maximum of them, but I have to return the longer one. In this case, I should return subsequence 2. Otherwise, I will return subsequence 1. Okay. Can only concatenate string to string. Tuple to string is not allowed. Why is tuple returned? BB. First three BB is printed out. Then BAB is printed out. So when A is returned here, what is returned actually? A is returned. Why now this is tuple? I have no idea. Wait a minute. So okay. So this returns string. This should return string. This should be string, I guess. But it depends on what is returned. And this should be, assuming there is string, this returns a string. Okay, so let me check it. So the problem is, as I said, this one is not tuple. And I will check What is start and end here? In case of 1 and 2, wait, what is this 04? 1, 2. Where is this 04 printed out? I see. I see. Okay, I understand. So when 04, this calls this Mach subsequence, and when it is 1, 2, it prints out B, space, and B. B and empty string and B, I guess. Yes. But it's okay, and it should be BB. But where is it? Then it returns B and topper and B. Yeah. Why is it printing this twice? B space and B, then B and A and B. I'm not pretty sure why this is called twice. Okay, let me change it. So instead of returning this, and I will return it in the end. And I will check what is returned in the okay, for 2, 3, this returns tuple A. In the case of 2, 3, because this is true in 130, this calls, this is B plus, wait, obviously this is wrong. In case of BB, it should return BB, but returns the tuple of A. Hmm. Okay, in case of 2, 3, now start is equal to end char. So in 137, it should return this. And in this case, the start char is B, and end char is also B, and Mach subsequence of start plus 1 to end minus 1. It should be 3 and 1. And in this case, this should be an empty string. But empty string plus BB plus. Yes, that works. We join it. Hmm. No, it doesn't work. It really doesn't make sense why this becomes the tuple in the end. Oh, sorry. This is the case BA. No. So this is else case. So when this is 2 and 3, it should be BA. So I go to line 137, and it should be start plus 1, which is 3 and 3, 3 or 2, 2. Yeah. So in this case, 3, 3, start is equal to end. So I will return single string, like A. And this should be B. So both of the ranks are the same. So read should be subsequence 1, which is this one. So this should be A. So A should be returned. Okay, I see. Here, there is a comma. This makes the single integer into tuple. This should be like this. Okay, good. Okay, it works. So this is how I return the longest subsequence in the top-down DP instead of the ranks. So let me work on it in the bottom-up DP. Actually, this is the most challenging part in this video. So what I can do. So now what I did is filling in the table like this. I don't know. Yep. Then when I get this, I originally written this. Okay, this should be 3. But here, this should be BBA, so this should be 2. And here it was, no, here it was BAB, so this returned 3. And here, this returned, this is BBBA, so it should be 3. Here, this was BBAB, so this should be 3. And here, this was 4. Okay. And I'm wondering, what is this for? What are 4 chars of this cell? So, mm, one approach I've just come up is I start from this and go to the cell which is one length shorter all the time, like this. No. Wait a minute. Okay, so when I define the string BBBAB, so what I can do is I start from here and try to, find the path which ends up with 1 without decrementing 2. So for example, 43311, this vertical path is not okay because there is 3 to 1 jump. But this one, 43321, this is okay because there's only one decrement by 1 or decrement by 0. And when I take a look at this, what I can say is here, this represents BBBAB, and here, this represents BBBA. And what I can say is if I move from here to here, there is one string length update. So this B, the gap char, should be included. And here to here, the same. But here to here, there's a jump, so this B should be included. And here, B to B, there is, oh, not jump, but one increment. So this B should be included. And here, this is 1. So I should include this. So in this way, I get BBBB. But the problem is how I can find this path. It's a bit annoying to find this. Because for example, if I start from here, I can't find the path. So I need to somehow find the good path in a smart way. It's a bit complicated. Let me think it a bit more simplified approach. So when I start from here, so I think one approach I can take is every time string is given, I will remember which char was chosen. For example, if I start from BBBAB and firstly I get B and B, this is always true. And when I get BBA, I don't know which of B or A was chosen. So yeah, I think definitely what I can do is I keep the longest string in the DB table. Like instead of just 2, I will, store BB. Yeah. I think that's one of the solid approach, even though it takes more space, complexity. So let me go with that. And here, so So this is how it works, I think. Okay. Let me execute my code. Good. Hmm? No. What is executed now? Okay, okay. Standard output. B, 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 B. Okay. Good. So this is the approach in which I stored the longest palindrome string itself, not the length, into the DP table. But I think it takes more space because each cell has each string. So I'd like to optimize more. I think that the solid approach I can take is instead of filling in the um, string into the DP table, I will store from each cell it came from. Yeah. Mm. I think that's one of the possible approach. Or probably I think I can create a kind of hash map, which, for example, which is like start to end and chosen char. Like this. So in this way, and always I don't have to store like start end 1 and 3 because if it is B and B, it always clears that I will choose both of them. But for example, if it is BBA, I'm wondering which of B or A I should give up and I should choose. So I think that's one of the possible approach. Mm. Okay, so let me implement this. So what I can do is okay. So from here, I initiate the hash map. Then here, I put it into the hash map. sub2 is n-1, so this means the start was chosen. Here, this should be end. Okay. So probably here, I guess the decision hashmap. Okay. So okay, I don't need ranks anymore. Good. So now I've got decisions hashmap. So from here, what I can do is try to choose strings to be stored. Then I should build the string and return it. So I think I can use the 2 pointers. Because I have to push element from the head, I will make it the Q. And for the last half, I will push the element from the last one to the in the reversed order. Okay, so the value is in this case, I firstly find this one first and this one first. Yeah. And then I will find this one B and B, which means that this and this is found in the sorted order. The list is fine. But for the last half, I will find them in the reversed order. So to push it into the correction, it has to be stack. Because in the list, I can't append from the head. And otherwise, here, I will use the decision map. Oh, wait. Yeah. So here, I will choose this one index, but this doesn't mean that I should give it up or not. Sorry. If I have if I compare char A and B, and if I choose A, it doesn't mean that A should be included in the subsequence. This just means that I give a B. Sorry, so it's a bit complex. I make it a change. this decision is give up decisions. Let me rename it. Okay. And also let me rename this. Give up start or end. Give up start. So in this way, I can get give up start. And if this is true, because I should give up the start, left plus equal 1. Otherwise, right minus. This is a decision make. Then I get subsequence. Max subsequence should be first half plus latter half. Then I should return length of the subsequence. Good. But key error 2 to 3. Hmm? But 2, 3. Hmm. Oh, sorry. Wait. So give up start is give false. Give up start is now true. Okay. Good. Accepted. Great. So I submit again. There 1, 2, 3, 4, 5. I see. So here I have to take left plus 1 equals right as the edge case. In this case, if there is the same, I should append both of these left char and right char. Otherwise, I should append only left or only right. Okay, I think this is it. Memory limit exceeded. I see. So, and I have to break here because this is edge case. I mean base case. Good. How to remedy exceeded. Okay. Okay, accepted. Great. So let me quickly wrap up my today's practice. So today I solved the question longest palindromic subsequence. And in this question, I'm given a string S and I return the longest palindrome subsequence ranks. Yep. I solved this question with top-down DP and also with bottom-up DP. Basically, I use the 2D DP table in the bottom-up DP approach. Yep, and that's it. And for, what is it? Yeah, and also as a follow-up, I return the subsequent string, not the ranks. Yeah. And in the top-down DP approach, what did I do? Yeah. The update I made was that in the recursive function, I return the string, not the ranks. And in the bottom deep approach, I stored not the ranks, maximum ranks, but the maximum subsequence in the DB table. So that's the update I made in the bottom DP. But for this bottom of DP, this takes more space complexity. So I came up with another solution. Yeah. Which was to remember the decision I made every time when I fill in the DB table. And after filling in the DB table, I follow the exactly same decisions to build the maximum length subsequence. A bit complicated, but it worked. Okay, so that's pretty much it. Thank you so much. Bye.